Okay, welcome to Tuesday, November 7th. This is our class session, and we're going to immediately build off what we did with complex numbers last week and start solving general quadratic equations. Now, it's very likely that you've done something with the quadratic formula or quadratic equations before, and if you haven't, don't worry, we're going to fully explain them here. But in particular, there are 4 methods for solving quadratic equations that you must be equally proficient at. And so that's going to be our mission today, is reminding you of all 4 methods and making you equally proficient at all 4 methods. So it could be that you've before just worked with the quadratic formula, or you just worked with completing the square, and they didn't get the same exposure to all 4 expressions. So that's what we have to do today. Make sure you're comfortable with all 4 methods of solving quadratic equations. Those 4 methods are factoring, which you've already practiced, and then the methods we're going to illustrate today: square root property, which is used in special cases; completing the square, which most people don't assign enough respect to. They figure it's extra work, and it's just surpassed by the quadratic formula. But all 4 of these are equally valuable. Let me take you to our website just to get you oriented and get you ready for this week and next week. I know that we're simply online all semester, but let me get someone else in the room here. Next week is Thanksgiving break week. So even though we're still meeting online, we're not meeting online for the whole week. Let me just point that out to you. So I'm going to share my webpage with you now. Here we are in week 12, and I'll even go back to our base page right here. Week 12, week 13, week 14. Week 13 is November 22 to 28. And the Delta College's ordinary schedule, which it'll still maintain this year, is that on Monday and Tuesday, classes meet as normal. And on Wednesday and Thursday, Friday, classes are not meeting for Thanksgiving break. Our class meets on Tuesday, Thursday. That means we will meet on Tuesday, but not on Thursday. So we have 2 sections we'll cover next week, and then we have Thanksgiving break, no class session on Thursday, November 26th. Okay, now as for your homework, where you normally hand in written homework and XYZ homework on Wednesdays, since we are not having any classes on Wednesdays, I gave you that Wednesday off. So look at your homework that you're preparing right now. On this Wednesday, November 18, you're handing in your written homework number 9 and the XYZ homework from 7-4, 7-5, 7.6 and 7.7. That was the material we covered last week. But then on the following Wednesday, you have no homework due, either written or online. And your next written homework is homework number 10, which I'll turn on tomorrow. And these sections 8.1 through 8.6 in the XYZ homework. Now notice that that's 6 sections in your XYZ homework, and you're used to doing 3 or 4 per week. This week we're covering sections 8.1 through 8.4, and next week we'll cover sections 8.5 and 8.6. So you have 2 weeks until the next XYZ homework is due, and it covers all 6 of these sections. So even though you're not having any XYZ homework sections due next Wednesday, you want most likely to get started on these so you'll be ready to have them completed by the following Wednesday. So as normal, our website is up to date, has all the information you need on it. Just pay attention to these due dates. Also, as you're handing in papers, please continue to pay attention to naming the papers properly. And I'm having a little bit of trouble in the cases where people are not writing their names on their papers. You might assume that your file has your name on it. Still, when I'm grading them, I would like to see your name written on your paper as you would in any ordinary circumstance, just so that I make sure that I do not mix up the papers or misreport any grades. So please put some care and preparation into your homework that you're submitting. Okay, let me get out of here. And let's go back to our paper. So these are the things we'll talk about today: square root property, completing the square, and the quadratic formula. And I'm going to post some additional handouts that you can use for a quadratic formula later, and I'll share those with you also on Thursday. Okay, back to the paper. So let's look at square root property and completing the square. And the next written homework, which you have due 2 weeks from Wednesday, after the one you had in this Wednesday, will involve these properties and graphing in addition. Graphing, something we'll be talking about later this week and next week in our single Thanksgiving week session. So we're used to solving regular linear equations. In a linear equation, like example, 3x minus 7 equals 5, you're usually just 2 steps away from the x. And you usually just have a single x that you're focused on. If you want to solve this problem, you're going to unwrap the left-hand side until you've isolated the x. And the 2 things that are being done to the x is first you're tripling the x, and then you're subtracting 7. Notice how you unwrap those in the opposite order. If you want to undo subtracting 7, you add 7 to both sides. And then if you want to undo multiplying by 3, you divide both sides by 3. So you're used to solving a linear equation, just a single x. Now what happens if I have something like this? Let's say that I want you to solve 3x squared. plus 5x minus 28 equals 0. This is a quadratic equation. And it's not just a question now of, oh, let's isolate x, like which x are you going to isolate, this x or this x squared? And if you solve for the x squared, you can't send the x over to the other side because you need to combine your x's. You need to get the x's together. What should I do with this x squared in general? Well, the technique that we've used so far is the factoring technique. If I can factor this, I could break it into two problems that look like this. So I try to factor this expression on the left-hand side. And the idea is if you multiply two things and have them set equal to 0, then one of those things must be 0. So first I say, how could I achieve the 3x squared? Maybe I'll take 3x times x. It's possible. Not many other ways I could do it. X times 3x, possibly, sure. I need now to have some factors of 28 that'll produce a 5 in the middle, a plus 5. So I know that 28 is 4 times 7. Now, possibly if I use 4 times 3x, that'll give me 12x's. And 7 times 1x, that will give me 7x. 12x, 7x, that could be differing by 5. I want one of these to be negative, and I want more positive x's in the middle. So here's a 12x minus 7x could be positive 5x. Let's assign the minus sign to the 7, plus sign to the 4. And check that I factor correctly. 3x squared, yes. Minus 7x plus 12x is plus 5x. Yes, minus 7 times plus 4 is minus 28. Now, I've resolved this into two linear factors, two linear equations. Since the product of these is equal to 0, then I either have 3x minus 7 equals 0 or x plus 4 equals 0. I can solve each one of these individually just like I solved this one. The first one on the right side is rather short. X equals minus 4 is the answer. And here, if I add 7 and divide by 3, notice I have a 0 on the right side, not a 5. Add 7, divide by 3, x is equal to 7/3. And these are the two solutions to that problem. So this is the only way so far that we've learned to approach quadratic equations. Is a linear equations, just a single power of x. Quadratic equations means you involve a square of x or a second power of x. As it turns out, almost always factoring is the nicest way to solve these. If a quadratic equation can be factored, if a quadratic equation can be factored, that is almost always the fastest way to do the problem. There are special cases where the square root property or completing the square might be faster, or the quadratic formula. But if something factors, we should always try that first. It's usually the fastest way to do the problem. For these other methods now, I'll illustrate each of them. We have to build. So what is the square root property? The square root property is a quick way to do quadratic equations that appear in a special form. For example, if you have this problem to solve, x squared equals 16. It's true you could factor it. You could bring the 16 over to the left, say x squared minus 16 is x minus 4 times x plus 4. Then say one of these has to be 0. So either x minus 4 is 0 or x plus 4 is 0. And you get your two answers, 4 or minus 4. So factoring is handy when it works. As it happens, this is a little bit long, even though this is short. This is long compared to the quickest way to do this. The square root property says, well, if you've got x as a perfect square, why don't you just take the square root of both sides? Now, when you do that, technically you have to remember that the square root of x squared is the absolute value of x. And the square root of 16 is positive 4. So we go back to the day where we solved equations like this. If the absolute value of x is 4, then there are two numbers that would make this sentence true. X is plus or minus 4. As it is, most people just say, I'll take the square root of the left side and I'll add a plus or minus in front of the root 16 to make this plus or minus 4. So some people don't bother to write with the absolute value. They just take the square root of both sides, write plus or minus in front of the answer. So this is a quick way to solve that problem. This is called the square root property. And part of the reason this looks attractive is because you have the square root of 16, and 16 was a perfect square. But I want you to observe that this works even if the number on the right side is not a perfect square. Let me give you some examples. Number this so I can keep track of the sheets. So, get my paper on the window, excuse me. Let me give you some other examples of the square root method. So if I said to you, x squared equals 9, the square root method would be a really nice way to polish that off. Square root of both sides, x equals plus or minus 3. But I could have x squared equals 8, and I could use a square root method. I could have x squared equals minus 25, and I could use the square root method. Remember, now we've allowed the square root of negative numbers when we use the complex numbers, when we use the square root of minus 1, which is I. I could even have a fancier thing on the right side being squared. How about x minus 4? Look at all 4 of these examples simultaneously, because in each one, I've got a perfect square of the variable or something involving the variable on the left side, and I've got a variety of things on the right side. Each one of these is excellent for the square root method. Square root of x squared plus or minus the square root of 9. X equals plus or minus 3. Now, notice when you write x equals plus or minus 3, you're writing two answers. Excuse me. But it's okay to write the two answers in this form, plus or minus 3, as long as it's clear what the plus or minus belongs to. This plus or minus belongs only to the thing that follows immediately, 3. Here I could say square root of x squared and plus or minus the square root of 8. But I need to do a little bit of work to clean up the square root of 8. And that's why we spent time working with radicals in the previous week. Think of this as plus minus 4 times 2. You don't know what the square root of 2 is, but you do know what the square root of 4 is. Simplest radical form. Pull out all perfect squares. So this is plus or minus. The square root of 4 is 2, and the square root of 2 is left behind. Okay, got that. How about dealing with the case where I have a negative number under the square root? Well, now we're allowed to take the square root of a negative number if we introduce the complex numbers. So think of the square root of minus 25 now as the square root of 25, which you know well, times the square root of minus 1. So x equals, there's 3 things here that you have to take care of. Plus minus, square root of 25, square root of minus 1. So x equals plus or minus, square root of 25 is 5, square root of minus 1 is I. Okay, there's also 2 answers right there. Plus 5i and minus 5i. How about this expression here in the last column? Now, the left side is a perfect square. It's a little fancier than the others, but it still is a perfect square, and I can still take the square root of both sides to find out what x is. I have to add 1 additional step. So I take the square root of both sides. Plus or minus square root of 7. Notice I don't know what the square root of 7 is. I mean, I could ask the calculator. I'll just leave it as square root of 7. There's no perfect squares inside there. But I can take off the square root of the x minus 4 squared. Just say this is x minus 4 equals plus or minus square root of 7. Now, it's really important that I keep the plus or minus only attached to the square root of 7. So now when I add 4 to both sides, I don't want to add 4 on the back side because I don't want you to think the plus or minus belongs to root 7 plus 4. Plus or minus only belongs to root 7. So to emphasize that, I am going to write the 4 first. 4 plus or minus root 7. Now, in the case where I still have a square root involved, right? If someone wanted to ask me what those 2 numbers were, I don't have any problem pulling out the calculator. So someone wants to know now, what is 4 plus the square root of 7? What is 4 minus the square root of 7? I'll acknowledge that I'm only giving them an approximate answer. And I'll go pull out my calculator over here. Let me use my old-timey calculator because it's got a slightly bigger screen and bigger letters to read. 4 plus square root of 7 is 6.646 if I round to the nearest thousandth. Someone always has to tell you where to round to if they want you to approximate. So I'll say 646. I'll round to the nearest thousandth. 4 minus the square root of 7. I can likewise approximate. It's 1.354. That 2, I don't round and increase. It's 1.354. Round down to 4. Even over here, 2 times the square root of 2, someone might be curious what 2 times the square root of 2 is approximately. And I don't mind providing that information for them. but I will tell them that I'm only giving them an approximate answer. Where should I stick this so it's not in the way? 2 times the square root of 2, 2.828 rounded to the nearest thousandth. And minus 2 root 2 is the same number with a minus sign in front. Okay, so sometimes people get in the habit when there's a square root involved that they always perform the extra service and give the approximate value. And that is fine as long as you give the exact value. Don't just give the approximate value. But it's not a bad service that when you have a square root in there, you present the exact answer and the approximate answer. You present the exact answer and the approximate answer. That way you're covered if they wanted the approximate answer. But you can go by the directions. If they don't ask you to approximate, just give the exact answer. If they ask you only to approximate, then you just have to circle the approximations. Let me give you a fancier square root method problem, based on this expression right here. So you see that adding the 4 after I took the square root was not such a big deal. Well, if that's the case, I could decorate that perfect square with lots of stuff. What if someone asked you to solve this? 2 times 4 minus 3x quantity squared plus 16 equals 0. I mean, let's make it really bad. This is going to involve several things, right? But the concept is still that I'm going to take the square root of this perfect square. That's the key concept, that I'm looking for x, and x is buried in a perfect square. So I'm going to dig it up and then open up that treasure chest by taking the square root of both sides. That's the square root method. Okay, so what do I have to do to prepare? I have to isolate this perfect square. So I'll subtract 16 from both sides. And I'll divide both sides by 2. Now I'm faced with a negative number here, right? Square of this is equal to -8. Now it's not a perfect square, but this is a perfect square. Before I didn't want to have negative signs when I took square roots, but now I'm going to allow that with complex numbers. So let's just drive ahead, take square root of both sides. 4 minus 3x squared, square rooted, plus or minus square root of -8. Now think about this -8. We've got the negative sign. Sure, this is going to involve complex numbers, but there's also perfect square inside there. So think about that as 3 pieces. Plus or minus 4 times 2 times -1. And the square root of 4 you understand. And the square root of 2 is some crazy number that you need a calculator to approximate. The square root of -1 now we refer to as I. So this is plus or minus 2 root 2, excuse me, move my paper up, plus or minus 2 root 2 times I. Be careful that that I does not belong under the square root. It's the square root of 2 times I, not the square root of the quantity 2i. Okay, that's what I see right there. So 4 minus 3x, after I take the square root of the square, is plus or minus 2 root 2 times I.
So just for clarification, the I does not go under the square root?
Absolutely not. That's right. Gotta be really careful. The problem is, thank you for pointing that out. Okay, now I see I gotta be careful to make sure I pin my paper recording, but thank you for asking that. The I does not belong under the square root because the I was this object right here. It was not belonging to that root 2. The problem is sometimes when people write this is they got root 2 times I, and then the next time they write it, they write root 2 times I, and the next time they write it, that I like kind of slides under there. All of a sudden it's under the square root, and some people say, how to get there? It doesn't belong there. So make sure you keep these very separate when you write them. Some people even write like this to make sure they stay separate. Some people write the I first and then the root. And that is acceptable if you want to write like that, just to make sure that you don't accidentally slide it under the square root. Okay, let's finish this expression here. So I want to know what x is, right? And I still haven't found out what x is. So the next thing I'm going to do is subtract 4 from both sides. And remember that plus minus only belongs to the 2 root 2 times I. So I keep the plus minus on the 2 root 2 times I, and I put the minus 4 out in front. That's a safe way to do it. And now I divide both sides by minus 3, which is a little bit awkward with this plus minus here, but here's how you could write this. X is equal to negative 4 over negative 3. That's 4/3. Remember, I need complex number written in separated parts, standard form. And here I have plus or minus 2 root 2I over negative 3. Well, that either gives me a minus or a plus 2 root 2I over 3. So whether I say minus or plus this or plus or minus this, that doesn't make any difference, because I'm only adding or subtracting this 2 root 2I over 3. That was still legally the square root method, but that was an excessive amount of prep. I'll accept that. But I was just using the square root method. Isolate the perfect square, take the square root of both sides, a lot of cleanup here on the right. And then I had to do further cleanup to isolate the x. So this would be square root method extreme case. But it might happen. So don't overlook it. Now, usually you're only using the square root method on these short and sweet problems like this. I even call this last one short and sweet because it still only took me 2 steps. 3 if you say add 4 to both sides. So the square root method is not for general problems, but it can still help you when you solve general problem. So this next method right here, let's prep this and we'll cover this before our break. This is where the square root method shines. And conversely, this is why people don't necessarily like the square root method, because they think it introduces this extra work that I'm about to show you, called completing the square. Completing the square is a special way to prepare a quadratic formula so that you can use the square root method on it. For example, if I said to you, x squared minus 4x plus 4 equals 25. You don't immediately think you could use a square root method on this. 25 is a nice perfect square. It's kind of enticing because you're not necessarily looking at this as a perfect square yet. But do you see that this is a perfect square? If you factored this, it would be x minus 2 times x minus 2. That is a perfect square. And now you could take the square root of both sides. Plus minus, don't forget the plus minus, root 25, and say x minus 2 is plus or minus 5. So x is 2 plus or minus 5. Now there's no simplifying, there's no approximating them, but I can simplify this, right? I do know what 2 plus 5 is, 7. I do know what 2 minus 5 is, negative 3. So if I go and check these out upstairs, if I put a 7 in here, 49 minus 28 plus 4, 53 minus 28 is 25. There's a winner. If I put a minus 3 in here, 9 plus 12, that'll be plus 12. 9 plus 12 is 21 plus 4 is also 25. Another winner. So sometimes you can use a square root method even though someone didn't write it for you at first as a perfect square. Now, what if they instead had written this? X squared minus 4x is 21. Remember what I just said on the left side. Once you realize that was a perfect square, you could use the square root method. Is the left side a perfect square here? No, the answer is no, because actually I'm lacking that 4. I could add 4 to both sides and then it would look just like that problem. But what if I didn't know that I was supposed to add 4? So this game is called completing the square. It means I will teach you how to make this left side a perfect square. And here's how you do it. And I will post some handouts illustrating this too before next class session. This is a very particular game, so watch closely. I create a space to insert this number that's going to make this into a perfect square. What number am I going to insert? Well, you take half of the number in front of the x. That would be minus 2. And you square it, and you get positive 4. Now, surprise, positive 4 was the thing I had to add to make that a perfect square. So I'm just showing you if that positive 4 was missing, how you could make it. You take half the number in front of the x, square, and insert that positive 4 on the left side. Add positive 4. Of course, that is not legal to just add 4 to the left-hand side. You've changed the problem. In order to not change the problem, you have to add 4 to the right-hand side as well. So I took half the number in front of the x, squared it, and added that number to both sides. Now that I've done this, I get the bonus. what's the bonus? The bonus is the left side is a perfect square. What perfect square? Well, I just wrote it right here. This left side is x minus 2 squared. What if I didn't know how this factored? Well, completing the square takes care of that for me. That minus 2 just drops straight into the perfect square. On this side, I have to figure out what 21 plus 4 is, but that's not a big deal. And now I'm ready to finish, just like I finished the last problem with the square root property. So the square root property is the tail end of completing the square. Now I want you to focus on the red stuff that I wrote right here. Shows up fairly well on the camera in red. It shows up also when I scan these sheets afterwards. I'll keep numbering my pages. The red game here is this game called completing the square. So you have to practice playing this red game. Now, it always works like this, except before you play the game, you have to make sure the number in front of the x squared is 1. But you always, the number in front of the x squared is 1. You always take half the number in front of the x with the sign, square it, add it to both sides, and then the left-hand side will become a perfect square just with that number. Just drop that number straight down. Figure out what's on the right side, and then finish as a finish now with the square root property. The fact that this is a plus minus square root of 25 is kind of a gift in this problem. It doesn't always have to be so nice. And I finish the problem by adding 2 to both sides.
So is there a way to make it so where, like, let's say it was 2x squared, is there a way to make it to where it's just 1x squared?
Yes, and that'll be the next problem I illustrate for you. And the way, it sounds kind of silly, but the way is whatever number shows up here, you divide everybody by that number. Now that's, first of all, that sounds too simple, but I can divide both sides by 3. There's 3 here. The problem going to cause me pain when that happens is I might have to create fractions. So let me illustrate that for you now, but I'm just going to finish writing down. 2 plus 5 is 7. 2 minus 5 is negative 3. So here's the good news. The completing the square method always works. Always on any quadratic equation, the completing the square method always works. Kind of the bad news is, or the not popular news, is that it could involve several steps and it can involve fractions. So you have to prepare this very carefully. So let me go back to the very first problem we did today. And then we'll do this and we'll take a break. you say it's 3x squared plus 5x minus 28 is 0? And I picked this problem because I already know the answers. But I want to show you when I promise you that the completing the square always works. It always works even on things that could have been factored. So let's take this problem, going to give me the ugly fractions. And let me show you how this works by completing the square. I'll write this down here. 3x squared. I'm just copying it off the paper above me, which you don't see, but I'm just copying the same problem. Equals 0. So let's solve this problem by completing the square. Okay, step number 1 is I've got this 3 in front of the x squared. And I don't have any space to put in the thing that can complete the perfect square. So first, I'm going to move the 28 over to the right. Add 28 to both sides so I can put in the number that fixes the perfect square here. I might have to go to another paper in a second. Next, I have to make this number in front of the x squared 1. I can't just erase the 3. I got to do it legally. And that means I'm going to divide everybody by 3. If I divide 3x squared by 3, I get x squared. If I divide 5x by 3, I get 5/3 x. If I divide 28 by 3, I get 28/3. And this is the reason why people don't always enjoy completing the square, because I got to get some fractions in here sometimes. Well, let's see what I can do. I'm going to use this method up here exactly. And every time I make it look exactly the same. That is, take half the number and square it and add that to both sides and then drop it down into here. Now that's a little bit off the top of my page, but let me see if I can bring my camera like a little bit slightly closer so you can read that easier. That doesn't work too nicely. Half of 5/3 with the sign, that will be 1/2 times 5/3, which is 5/6. So that's literally 1/2 times 5/3 with the sign. Squaring that is not going to be the easiest thing I ever did, but it's not that bad. 25/6 squared, I'm sorry, 5/6 squared is positive 25/36. And remember, that's what I insert to complete the square. But to make it legal, I have to do it on both sides. Now you made a perfect square on the left side. And at first you're kind of like intimidated, like what perfect square? I don't see it. And that's why I tell you, all you got to do is drop down this plus 5/6. You get my different color pen and square it. And this will produce, if you FOIL this out, x squared plus 5/6x plus 5/6x is 5/3 x, plus 5/6 times 5/6 is a 25/6. So this number that you create right there is automatically half of that 5/3 is automatically the number you write for your perfect square. I got work to do still on this side. I got to think about 36. If I multiply 3 by 12, I get 36. But shoot, I got to multiply 28 by 12. I'm not going to enjoy that, but that's the way it is. What's 28 by 12? 2, 16, 8, 280, and 56. Is that 336? I think so. But I better double check that on my calculator so I don't screw up. 28 times 12. 336. Okay. Let's add 25. I'm going to make this 361. And that's the number that goes right there. 361 over 36. Now this is the part where I said I got to move to a different paper now. So let's finish this off, then we'll take a break, but I'm just going to take this paper off and continue it on the next page. So completing the square can take some writing. How do I complete this now? Take the square root of both sides. Don't forget the plus minus. And now I got to think about 361 over 36. Now 36 I know is a perfect square. That's going to be 6. 361 kind of rings a bell. So I'm thinking to myself, am I going to get lucky? Square root of 361. I think that's a perfect square. It's 19 times 19. Now, if it wasn't, I'd have to hunt for any of the perfect squares inside 361. Excuse me, put that in the light. But 361 square root, thankfully, is perfect square. 361 is perfect square, 19 times 19. So this is actually 19 over 6. So x plus 5, 6 is plus or minus 19 over 6. Now I'm going to subtract 5, 6 from both sides. And remember, there are two answers here. So you have to write the two answers. Negative 5, 6 plus 19 over 6. And that is 14 over 6, which is 7/3. And the other answer is minus 5, 6 minus 19 over 6, which is minus 24 over 6, which is minus 4. I got to go back to that original problem, but you see that that's the same answers that we had before. I sure like factoring better. And that's what I want to say to you. If something factors, that's almost always the fastest way to do the problem, factoring. But there's a little bit of comfort in this. Completing the square never fails. So what if you were looking at this and you didn't see the factoring? It's possible. Completing the square will not fail you. Completing the square gives you the same two answers. Okay, got that, got that. That is almost, let me get this all on one screen. That was a lot of work. And it started right there and ended right there. So I would say this is almost the worst case scenario. Maybe I got to try another complete the square, because maybe it could get worse. if this wasn't a perfect square, or if I had some imaginary numbers involved. If I had squared a negative number, that might have made it a little bit worse. But this is almost the worst case scenario, dealing with fractions. Still, here's the game. This is the game you have to learn. Half that number, square it, add it, drop it down. That's the game you're playing. It's called the completing the square game. And if you learn that game, then you can solve these problems by completing the square. Okay, I am going to take a look at the watch here. So we're talking about 58, add 3. Let's take a break, stretch your legs. Come back in 5 minutes. And we will try this completing the square again before we move on to the quadratic formula. Okay, so I'm going to mute my microphone while I just stretch my legs a little. Okay, we're back here. An extra minute because I wanted to set something up for you here. And let me get, I promised you I'd have some handouts that would help you. So I want to add these directly to my website right now. So let me get a link for you and set this up and then show you those handouts. Here's the first one. And here comes the second one. So give me a second while I adjust the website right here, and then I'll show you what it looks like. And I've got a handout to help you practice the quadratic formula. Okay, got it. Put it in here. Got it. Save. Upload. And let's see if we got this in the right place. Okay, good. So let me show you what I just added to the website, because these handouts will be useful to you. I'm going to move over to my website, share screen, and this is our week 12 page. And I just added something to the handout section. So I had to refresh this page. Sometimes you want to make sure you got the most current stuff on our website, just refresh the page. And you see that I added 3 handouts here, the quadratic formula, completing the square examples, completing the square in the quadratic formula, or the quadratic formula. I'll show you what these look like. I'll just have to let them load here. Oops. It's loading, but it takes a second for this to load. I'll give it a second to load right here. There you go. And here's some harder completing the square formula. So let me show you these 3 pages that I just added. You should probably print them out and practice with them. On this first sheet, I give you 3 formulas or 3 examples, maybe 4 examples where you complete the square. Yeah. And I arranged them in a funny way on this page. So pay attention to how I wrote this. I wrote 4 examples of completing the square across the top. And these 4 examples are ones that are going from easy to complicated. And I'm doing the 4 examples as I move down the page. And the one on the left is the simplest. So I don't have to do as many steps. But the one in the second column is a little bit messier because it's got more steps. The one in the third column is going to get me some fractions. And that's going to be extra work, a little bit like what I just did with the fractions. And then here, the one in the fourth column's got fractions and complex numbers. So that requires even more work. Okay, so I just wanted to give you full 4 examples of completing the square completely worked out with the explanation 1 step at a time. Move the constant term to the other side of the equation. complete the square, set the leading coefficient 1. So I gave you every single step here. And on these last two problems, that involved a lot of writing. Okay, that's the handout called Completing the Square. Examples. Now, what we're about to do is use the complete the square to do the quadratic formula. So I want to show you side by side, if I have a problem where I complete the square, it actually creates what we call the quadratic formula way down here at the bottom. This is the famous formula down here at the bottom called the quadratic formula. But the quadratic formula is made by completing the square. So on this paper, I did one step at a time, taking a quadratic equation, setting the number in front of the x squared equal to 1, taking half of the number in front of the x, squaring it, adding it to both sides. I slowly built the quadratic formula until I get down here at the bottom and I have the famous quadratic formula. So you could see that happening side by side with a real problem. I did that on a generic problem here, 2x squared plus 5x plus 1. So this handout lets you see the steps of completing the square again and see how that builds the quadratic formula. Okay, that's the handout, Completing the Square and the Quadratic Formula. Third handout that I have there is just a handout to help you practice the quadratic formula. So if you have any quadratic equation, the quadratic formula always works. You have to use it carefully, and you have to identify the pieces accurately. So here's an example of using the quadratic formula to produce an answer in a case where I could not factor and I had real numbers for my answers. And here's an example of quadratic equation that has complex roots. And I create those complex roots with the quadratic formula. Okay, good. So print those out and add those to your handouts that you keep track of when you're just practicing problems or getting ready for a test. Let me eliminate that sharing. So I'll go back. Remember, that's in our handout section for this week on the resources too, but you have to refresh this page to get these new quadratic formula handouts. Okay, stop sharing, back to paper. So I'm going to pick out one more problem where I complete the square, and I'll make it a messy one that involves complex numbers just so we can practice that. But completing the square is this game that we described here in red. If you follow the steps of this game correctly, then you'll complete the square correctly. It's this game that I described here in red. So let's try something like, I don't know, 2x squared plus 6x plus 7. I don't want to make it too messy, but a little bit messy. Let's solve this quadratic equation by completing the square. Okay, step one. Let's get all the pieces. It's not an equation yet until I say equals 0. And you have to start with this thing equal to 0. Maybe you can factor it. If you can factor it, don't overlook that. But if they say by completing the square, then you have to illustrate our technique. But I'm going to start by creating space over here on the left side. Subtract 7 from both sides. I have to make this number in front of the x squared a 1. So I'll divide everybody by 2. Actually, that's kind of nice right there. I mean, at least, no fractions yet, but there are going to be some fractions coming. Here's a fraction, minus 7 over 2. Now we got to do the complete the square game. And the complete the square game is what? Take half the number in front of the x, and that includes the sign. Square it. And that includes the sign. Add that squared number plus 9/4 to both sides of the equation. And this left side is now a perfect square. And you say, I don't see that. I don't see how that factors. Well, you don't have to. You have the perfect square built right here. You just drop down that -3 or that +3/2, half of that number in front of the x. And that gets you the perfect square guaranteed. Foil it out and see. X squared, got it. +3/2 x plus 3/2 x plus 1.5 x plus 1.5 x makes +3x. Got it. And 3/2 squared is 9/4. You got it. Over here, I got to simplify. Say, got to get common denominators. If I make 9/4, if I make the common denominator 4, so multiply by 2 top and bottom. And this is minus 14 over 4 plus 9 over 4. So what is that? Negative 5 over 4. Okay, I'm going to take the square root of both sides, but here comes an I. Here comes an imaginary number, right? So now we take that. Remember this game. Game over. We've completed the square. This game right here with this red work, I try to keep my color consistent today. That's the part that's called completing the square. Now I got to use a square root property to find out what x is. X plus 3/2 squared plus or minus the square root of negative 5/4. Now I got some work to do. I understand the square root of 4. That's nice. But square root of 5, no perfect squares inside that. I just have to leave it as is. But the square root of -1, that's the I. So think about this as 3 pieces. Square root of 5, square root of -1, square root of 4. You got to deal with all 3 of those pieces. Square root of 5, you can't do anything about. There's no perfect squares inside the square root of 5. But the square root of -1, you have to write as I. And square root of 4, you have to write as 2. That doesn't become much prettier, but it's a little bit prettier. So I got x plus 3/2 equals plus or minus square root of 5 over 2 times I. Now I subtract 3/2 from both sides. And I keep that minus 3/2 in front of the plus minus root 5 over 2I. That plus minus only belongs to the root 5 over 2 times I. Pay attention to the position of this I, right? The I was in the numerator. You know, if I say to you 1/3 x, it's the same thing as saying x over 3, because 1/3 x is 1/3 times x over 1. You would not write 1/3 x, letting that x slip into the basement. That's not true. So when you have the x on the side, don't let it like slip down into the basement while you're writing. And the same thing with the I. The I belongs to the numerator. And so you can write it on the side, multiplied by this fraction, but do not let that I like slip down and say divided by 2i. You are not dividing by 2i.
Hey, Professor, I have a question.
Go ahead.
So for this problem, you left it as -3/2 plus or minus 5 over 2i.
Yes.
But the last problem we had, it was -5/6 plus or minus 19 over 6.
Good.
So if we had, do we have to simplify it?
Right. So have I simplified both of these problems? And the answer is yes. Remember, I said this last time. When you have complex numbers, that is the one time where I will not make you put them together in common denominator. You must always keep your complex numbers separate and in standard form. Now, over on the top, which you were right to say, these are just two ordinary Joe fractions. And so I'm supposed to add them together when I get common denominator. That's why I created these two answers. But you actually get a break when you're doing the complex numbers, is that nobody wants you to put them together. In fact, they actually forbid you from putting them together. You have to leave these separated in standard form. Do not write one fraction here. So that is legally done. Up here, I wouldn't have called this done. If you hadn't simplified that, I wouldn't have called it done. Okay, that's a really good observation. Okay, now how about completing the square on that problem? It's a lot of work. Here's the red stuff. Oh shoot, I got an imaginary number. Got to do something else. Again, this is close to like this almost worst case scenario. Fractions, roots, imaginary numbers, got everything. But this technique, you could take this to the bank, always works. As long as you do it properly. Always works. It never fails. Now that's contrasting with factoring. Sometimes things don't factor, and that's just tough luck. But completing the square always works. I want another method that always works. And that is the famous fourth method of the day. Been a little bit busy today. Factor, square root method. I'm going to go back to page 1. It was so long ago we might have forgot. Oh, sorry, didn't mean to poke you in the eye there. Factoring, square root method, completing the square. One more famous method. So I want you to be the 4-tool quadratic equations player. I don't know how many of you like baseball or who your favorite team is, but when you got a excellent draft pick in baseball, what do they call them? They call them a 5-tool player. Anybody know what the 5 tools are? I mean, if you got 4 tools, you're a good draft pick. But a superstar going to be a 5-tool player. That means they can run, field, hit for average, hit for power. Now I got to remember what the 5th one is. Any baseball fans in the audience?
Yeah.
What is it?
Can you repeat the question?
When they say you got a 5-tool player, what are they talking about?
Oh, someone that can do, hitting, running, fielding,
Right? 3.
oh,
And hit
hitting,
for
running.
average and power. So that's 4. What's the 5th one I missed?
I don't
Okay,
know.
I got it. I just Googled it. Hit for power, run, field, and throw. They got to have an arm.
Oh,
Okay,
yeah.
got it. Okay, so I'm only saying this to kind of plant this funny thing in your mind. I want you to be a 4-tool quadratic equation player. I want you to build a factor, use the square root property, complete the square, or use the quadratic formula. That's the last one I'm going to show you today, quadratic formula. Then you'll be a 4-tool quadratic equation player. Okay. And we're going to still be practicing these all next week too. This quadratic formulas, quadratic equation, very important. And like I said at the very beginning, you've probably done some of this. Maybe you've done most of it. But my job is to make sure you know how to do all 4 equally well. That's my job today, at least to show you how to do it. So here's the quadratic formula. If you have a quadratic equation that someone hands to you, and that means anything times x squared plus anything times x plus any other number equals 0. Then there's actually a formula that solves it for you automatically. But it requires practice and it requires care. It's called the quadratic formula. And it goes like this. X is the opposite of b plus or minus square root of b squared minus 4ac divided by everyone divided by 2a. Now the pain of this is you got to remember the formula and you got to remember it correctly and you got to use it correctly. So, I mean, it's worthless to have a perfect formula unless you remember it. And it's worthless to have a perfect formula unless you can execute it properly. You know, that'd be like giving me a fancy high-powered drag racing car. It doesn't matter if you give me a fancy high-powered drag racing car unless I really know how to drive well on a drag strip or on a speedway, right? I can just drive ordinarily. Okay, so quadratic formula, let's practice using this. And I'll show you how I practice using it. You can do it differently, I don't mind, but I'm going to show you a good way to practice it. People remember this all kinds of fancy ways. They remember it by singing it. I'm not going to sing it. They remember it by making it match their school fight song. I don't even remember my school fight song after this much time. So I don't care how you remember it, but you got to remember it. And these numbers A, B, and C that go in here come from the problem. So let me pick out one like we've been doing. In fact, why don't I pick out the very first one we started with today? Mostly because I already know the answers. And then I'll know whether I got it right. So I put that paper off the top of the board, but let me just write down that equation. 3x squared plus 5x minus 28 is 0. Okay, so here's the first step for doing this. In my book, this is how I do it. You do it the way that works for you, but it's got to work. And it wouldn't hurt to follow this recommendation. First thing is I write down the A, B, and the C. And if there's a negative sign there, that belongs with the number. So C is minus 28. Here, B is positive 5. You could write positive 5. I wouldn't mind. Here, A is positive 3. Step number 2, and I'm going to overwrite here. Step number 2 is I write the quadratic formula on my paper, just so I practice remembering it. Again, this is what I do. Step number 3 is I rewrite this. Just leave parentheses in place of every number I'm going to insert. So far, you're not complaining. But then some people say, oh my goodness, are you going to write parentheses in there? Why did you do that? I don't need to do that. Well, I'll tell you what the parentheses do for me. They protect me if one of these numbers is negative. So generally, they're going to protect me so that I don't screw up the signs. Let me write this in now. Oops, I forgot the bottom. Don't forget the bottom. 2 times A. Now let's put in the A, B, and C. Now the B was just a plus 5. And then here's a B squared, going to be a 5 squared. The A right here is 3. I didn't leave myself a lot of room. The C is minus 28. So I'm sorry, I got to squeeze in the minus 28 there. Remember the bottom? 2 times A, 2 times 3. But I'll tell you what people do with this bottom that gets them in trouble is they say divided by 2A, but they don't put the 2A under both of these pieces. Sometimes people just write this casually and foolishly by saying B squared minus 4AC over 2A. Sometimes they only put the 2A down here. This is deadly wrong. So I don't even like to write stuff that's wrong because then people copy it anyway, just accidentally. Keep that 2A under the whole mess, both pieces. Okay, now you're on the downside of this problem and all you gotta do is clean it up properly. So opposite of 5, got it. Plus minus, but there is still danger here. And the danger is in cleaning up inside the square root. So let me tell you how I deal with that. Say, don't try to do all the numbers and all the signs at the same time. Just write down the 2 numbers. 5 squared is 25. It's a positive 25. Even if that was a minus 5 squared would be positive 25. That's what the parentheses do to help me. Now what's 4 times 3 times 28? We actually did that earlier, didn't we? 4 times 3 times 28. I actually typed that in the calculator earlier, but I think it was a 336. Yeah. 4 times 3 times 28 was a 336. And then put the sign in here correctly. Why is it a plus sign? Because I had a minus times a minus. That makes the plus 336. Sometimes people are trying to do these numbers and the sign at the same time, and they screw up. So first do the 2 numbers, then put the right sign in the middle. Okay, I'm rolling. Bottom is a 6. Now it's going to look more like what we did once, isn't it? 25, 336 is 361. And I remember how that turned out to be a perfect square. So I have minus 5 plus or minus square root of 361, which was 19 over 6. And remember, that's two answers. And I can clean this up. So minus 5 plus 19 is 14 over 6, which turned out to be 7 over 3. That was one of my answers in the first problem today. Then the other one, minus 5 minus 19, going to be a minus 24 over 6. And that is minus 4. That is the other answer I had at the beginning of today. Now that is a lot of writing. I don't deny that's a lot of writing. Maybe it's not as much writing as completing the square, but it's still a fair amount of writing. But it is the same answer I got at the very beginning today, right? What does that remind you of? If you can factor, do it, because it's going to save you a lot of time and pain. You know, if someone wrote on your paper, just solve this quadratic equation any way you want to. If it factors, just factor, because that's the easiest and fastest. Some things don't factor. Okay, since some things don't factor, you got the quadratic equation, you got completing the square. But here's the good news again. Quadratic formula always works.
So is there any possibility of getting extraneous solutions with this method?
No, and that's even better. There's not even any traps. Same thing with completing the square. Now, you're going to say, well, that sounds too good to be true. How's that? And the reason is because I'm not taking the square root of anything anywhere. I'm using just the procedure of completing the square. I was getting extraneous solutions the other day where I was taking the square root of something. But here, even in completing the square, I'm only taking the square root of perfect squares. So that is a good news. Quadratic formula always works. And by always works, I mean it only tells you true answers. Now you're saying, well, never say never, never say always. There's got to be some catch somewhere. And if there is, I'm gonna, and we'll, like I said, we're gonna do this next week too. If there is, I'm going to defy you to find it. Quadratic formula always works. Completing the square always works. Now there's a caveat. There's a fine print. Fine print is you have to execute it exactly correctly. Of course, nothing's going to work if you mis-execute it. And that's why you got to be really careful with the signs and the parentheses and the simplifying. I'm going to try another one that doesn't come out so sweet. Right? So you got to follow all the rules along the way. But this is just my recommendation. And it turns out in the cosmic scheme of things, this does not take a lot of time. Write down the ABC. Write down the formula until you've memorized it correctly and you're sick of it. Rewrite the formula with parentheses so you can carefully insert the numbers from above. You don't have to use different colors. That's up to you. But I'm inserting the numbers from above. Step 4. Simplify, and you're done. So 1, 2, 3, 4. Okay, let me try another problem. Let's see if I can get something messier. See if I can get something with complex numbers in it. Show you the quadratic formula works even if you have complex numbers. So let's talk about x squared minus 5x plus 12 equals 0. let's solve this with the quadratic formula. And I'm not picking a nasty one. This is just kind of I would call this one a medium. And the reason I'm going to call this one a medium is because there is going to be some complex numbers here. But the numbers are not too huge and nasty. Okay. Step one. What's the A, B, and the C? Notice the B is -5. So if there's a sign there, it belongs to that number. -5 plus 12. I don't write plus 12. You can, but I better write -5. And the A here is 1. Don't say there's no A. There's a 1 right there. Okay. Step 2. Write the quadratic formula down until you can repeat it in your sleep. Everybody divided by 2a. Opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Step 3, I'm going to rewrite it and let myself have plenty of space with parentheses for all the numbers I'm going to insert. And this is mostly to protect me when I have to put in minus signs. That's what this is good for. Now I'll put in the numbers. Say the B is -5. So right off the bat, I have -5. That'll turn into a +5. The -5 squared gonna turn into a +25, not -25, because I'm squaring the minus sign. A is 1, C is 12. That one's not as nasty as the last one. Bottom is 2 times 1. Okay, now step 4, execute and simplify. So opposite of -5, you got that. But here's my instructions about underneath the square root. Don't try to be squaring, adding, subtracting all at once. Just tell me these two numbers. First number is 25. Second number is 4 times 1 times 12. It's 48. After you do that, then tell me whether you're adding or subtracting. 1 minus sign. I am subtracting. That just makes it nice and safe. Bottom is just a 2. So we're just going very slow. Let's see, here's what I depend on. And that's why when most people say, this is too slow, I can't take this, I'm just going to do it. I promise you that if you do this slowly, then 3 or 4 or 5 days, even if you've never done this before, you're going to start doing it fast, right? How's that saying go? I'm talking about, you've heard this saying, slow is fast, fast is what? No, like special forces, like Navy SEALs say that. You know what I'm talking about? Time for Google again. Oh, I got it. Okay, slow is fast, fast is smooth. Sometimes the special forces say that. The idea is you're not trying to rush, you're trying to do the job correctly. So if you move slow, you will move fast. If you move fast, you will be smooth. And that's your goal, is to not be slow, not be fast, not be the champion for speed. Your goal is to be smooth and do the job right. Okay, slow is fast, fast is smooth. So if you practice doing it this way, you will get faster and smoother. Okay, let's finish. 5 plus or minus. 25 minus 48. Oh, here comes the minus sign. Here comes negative number, right? Say, got 25 minus 48 is 23 negative. I got to respect that negative. It's there. Divided by 2. But actually, I'm done, just about done. The only thing I do is clean up this square root of 23 negative. Now, are there any perfect squares inside 23? No, not really. I can't think of a 1. So I am just going to write square root of 23, square root of minus 1. That's the square root of 23 times I outside the square root. And that's all I got to do to finish, except one thing. Now remember, this is a complex number. This is not separated. So this is not standard form. And I'll tell you, people will be very, very picky about that, including me. Now, if it was me, 10 points, and you stopped right there, I'd give you an 8 or a 9. Because people are really, this is really, really important to people. So you got to finish it by separating it. It's like the only time in your life where you take the common denominator and separate it into 2 fractions. But it's not hard to do. This is standard form. And now that this is standard form, you're done. Game over. And it took a fair amount of writing, but it wasn't so bad. It wasn't so bad if you just take it one step at a time. Okay, good. I don't know what I want to say about this. I guess it could have been worse if there was something to clean up inside this root 23. But I guess I'll just consider that to be a gift. Like someone made the problem shorter. That's okay. How can you see these 2 answers in a graph? I will show you that, but that's next week's work. So whenever you're saying, you know, here are the 2 answers to the problem, how am I supposed to see them in a picture? I always want to say to you that solving and graphing is the same thing. So we will do that when we do some graphing next week. But right now you're done. Standard form of complex numbers. This is A plus B I. Oh, by the way, I don't mind if you write the plus and minus in there. In fact, I don't even know anybody that makes you separate them. But I do want you to see that there are 2 answers there, right? But you don't have to write them separately. Maybe if you had 2 answers that someone wanted you to approximate both of them separately, then you should write them separately. But in this case, unless they told me to give some approximate values, I'd just leave it like that. Oh, sorry. I would just leave it with plus minus. That's perfectly okay. Okay, so actually we did a lot today if you consider all 4 methods. And you've seen some of the methods before, but I wanted you to see them all side by side next to each other. Factoring, square root method, completing the square quadratic equation. We're going to do more next week with these, but we're going to add the graphing. Go look at the handouts I posted that I showed you when we came back after break today, and work your way through the exercise, the problem on the handouts, even the messy ones. And then after a while, they won't seem as complicated or messy to you. Okay. We have one more session this week on Thursday. And then remember, as I showed you, we have only one session next week. So you got a slight homework schedule break there. Make sure you pay attention to that. I'll talk to you guys again on Thursday. You have a nice afternoon.